we are talking about this grand adventure of artificial intelligence. And artificial intelligence is the art of making machines smart. So in your home, or at least in my home, the smartest biological creature is my dog Denver, followed by my partner, and then me. But we are filling the home with machine intelligent devices. The tool that is now commonly used to make machines intelligent is what we call machine learning. I'll talk about that in a minute. And first, just use an example from spam to make it real. In the old days, on the left of the screen, people would program something to say, if you write a computer program that is supposed to identify spam, make it explicit. In other words, you would find words that were indicative of spam. You would do a computer program that says, if you find this word, mark it as spam. But this was a very human-intense activity. On the right is the new model, what we call machine learning technologies, where no human has programmed it. No human has said, this is indicative of spam. The system learns what is characteristic of spam. And over time, the more information it has, and the more it's able to do, the more it gets the ability to identify something as spam that no human being has ever indicated as such. And I want to give an example of how the learning takes place. And it's in two steps. First, it's in training, and then the next slide in testing. And I'm using this example of cats and dogs and image recognition technology, but you could use any technology that you wanted to demonstrate this point. And what we're looking at here is an input and an output, and the process through which you get from point A to point B. So the input here could be literally millions and millions and millions of photos that have been labeled by a human as cat or dog, or have been labeled as Stuart Dresner or whatever else you want to label something as. And the system is meant to learn the characteristics in computer language of what a cat would look like. What are the shapes broken down in a way a computer would understand? Deep neural networks is a technique, much like our human brain, where one element can be broken down into many, many, many different elements, and it creates levels of abstraction to come to the output. The goal, of course, is to be able to identify, is that image a cat or a dog, or Stuart Dresner, or whatever else that we're trying to identify. And here you see the example in testing. As the system works its way through millions of photos that have been labeled by humans, it gets better and better at doing this. But the output can still be supervised by humans and say to the system, for example, in this example, you misidentified what the item was. Go back and redo it. Reprogram, reconsider what went right or what went wrong. It's this cycle. Now you see in the examples that I'm giving you, the input and the output are two places that have a lot of influence on the quality of the algorithmic outputs. That is also fundamental for the privacy analysis. What are you training the system on, in other words? And it's also fundamental to look at the outputs to say, is it actually doing the right thing? We'll come back to both of those concepts in a minute. But I want to show people that this is not science fiction. This is not the world 20 years hence. This is now in large-scale use across Google and many other places. This is just an example of how we're doing it at Google. Those of you in the tech sector know and recognize the hockey stick as the famous moment of inflection. I've been in the field for many years, and whenever you see these hockey sticks, you know something really fascinating is going on. And look, the time, we're just talking about a 2-year period here. If you look at Google services, and I'll just use these as examples, this kind of technology is also deeply embedded in basically all of them. I gave you the spam example, but you could look at many examples. If you're on YouTube, you could have the engines that try to figure out what will interest a person, what we call video recommendations. I'll come to the examples of translation and other things in a moment. The beginnings of smart replies in emails, where the email is actually trying to predict what a human chat response would be and how photos are organized. But let me take the example of translation, because this is one of the areas where computers have made the most progress in recent years. And look at the blue over here. This is the quality of machine translations in various language sets based on what we call phrase-based translations. But with this neural technology, we're getting this incremental green improvements, as you can see. Perfect translation is the line that you see nobody reaches, including humans. So this is a goal that we're trying to get to. The human incremental improvement over the machines is now really quite small, if you look at the graphs. This is startling stuff. And the example here is when we talk about this new neural network technology and the ability to improve machines using natural human language, it's because they can take not just a word translated to a word or a sentence translated to a sentence, but they can take a phrase and they can take context. They can think in terms of paragraphs, just as we as humans do when we use our own natural human language. That's the revolution here. And that's why we will get to essentially human quality very quickly. As you see, the Spanish-French version is very close already.